When we have a sine term and a cos term added together, we can simplify it to get it into the form r sine x plus alpha or r cos x plus alpha using our addition formula. So we can, instead of having two terms, we can simplify it to one term using our addition formula. This one shows that you can express 8 sine x plus 6 cos x in the form r sine x plus alpha, where r is greater than 0 and alpha is between 0 and pi over 2. So it's sine x plus alpha, so it's going to be sine a plus b. So our sine a plus b is sine a cos b, this is in the formula book, plus cos a sine b. I'm going to change a to x, b to alpha, and I'm going to multiply through by r. So it's going to become r sine x plus alpha. So I'm multiplying every term by r, so then equals r sine x cos alpha plus r cos x sine alpha. So this is what we're going to be using. That's our version of our addition formula. And then we need to look at what we actually have, which is 8 sine x plus 6 cos x. So now we can compare these two lines. So there's a sine x here and a cos x here. So to make 8 sine x plus 6 cos x equal to r sine x plus alpha, r cos alpha is going to have to be equal to 8. And r sine alpha is going to have to be equal to 6. Now we need to solve these simultaneous equations, and we will have r and alpha. To find alpha, we do the sine one divide by cos, because sine over cos makes tan, and the r's will cancel out. So this equation over this equation, r sine alpha over r cos alpha equals 6 over 8. The r's cancel out. Sine over cos makes tan, so we get tan alpha is 6/8. So shift tan 6/8 or 3/4, and we get 0.644. So alpha is 0.644 radians. To find r, we use Pythagoras. I'll do it first, and I'll show you how it works after. So it is simply a squared plus b squared equals c squared. 6 squared plus 8 squared equals r squared. That's a 3, 4, 5 triangle. 36 and 64 make 100. Square root 100 is 10. R is 10. So it is 10 sine x plus 0.644. So that is the same as 8 sine x plus 6 cos x. I'll show you how the Pythagoras thing works now. I'll do it on this side. So we had r cos alpha is 8, r sine alpha is 6. We're using the identity cos squared alpha plus sine squared alpha equals 1. Cos alpha is 8 over r. Sine alpha is 6 over r. So we have 8 squared over r squared plus 6 squared over r squared equals 1. Multiplying by r squared, 8 squared equals 6 squared. 8 squared plus 6 squared equals r squared. So that's where it comes from. You don't have to do this every time. You don't have to substitute into the identity. You can just go straight to using Pythagoras. Okay, so one for you to try. See if you can give it a go. So it's cos A minus B this time. So we're going to write down our cos A minus B. So cos, well in this case, x minus alpha. And times it by r. I'll do it in one step. So cos A minus B is cos A cos B. So r times cos x cos alpha plus sin A sin B. So sin x sin alpha. So it's just our addition formula, but with A changed to x, B changed to alpha, and multiplied through by r. Then we're going to need to compare. So if r cos x minus alpha is going to equal 5 sin x plus 12 cos x, we need to compare these two. So they're equal. And we're actually going to have to write it the other way around. So it's going to have to be 12 cos x plus 5 sin x. So let's compare. We've got cos x here and cos x here, sin x here and sin x here. So what's left? 12 equals r cos alpha, and 5 equals r sin alpha. To find alpha, we do sine over cos. So our sine equation divided by our cos equation, so that'd be 5/12 equals tan alpha, shift tan the 5/12, 0.395. And to find r, we're using Pythagoras. 5 squared plus 12 squared equals r squared. It's another Pythagoras triple. It's 13. So we have 13 cos x minus 0.395. Another one, show that you can express 2 cos x minus 3 sin x in the form r cos x plus alpha, where r is greater than 0 and alpha is between 0 and pi over 2. So it's our cos A plus B this time. So cos A plus B is cos A cos B minus, I'm multiplying through by r as I go, sin A sin B. And we have 2 cos x minus 3 sin x. So let's compare. 2 has to equal r cos alpha. And 3 is r sin alpha. To find alpha, we do the sine over the cos. So 3 over 2 is tan alpha. So shift tan 3 over 2, 0.983. And to find r, we use Pythagoras. So 2 squared plus 3 squared is r squared. So r is square root 13 this time. So we have square root 13 cos x plus 0.983. one for you to try. Give it a go. So this time we've got r sine x minus alpha. So it's sine a minus b. So our sine a minus b is sine a cos b minus cos a sine b. So again, we're going to compare 5 sine x minus 12 cos x. So we can see that 5 is equal to r cos alpha. And 12 is r sine alpha. To find alpha, sine over cos. So 12 fifths is tan alpha. Shift tan 12 fifths. 1.18. Pythagoras to find r. 5 squared plus 12 squared equals r squared. R is 13. So we have 13 sine x minus 1.18. In this question, we are going to write our expression in the form r sine x minus alpha, and then we're going to go on to solve it. Writing it in this form is useful for solving it. It's difficult to solve sine x minus 3 cos x equals something. If you put it in the form r sine or r cos, we can do that easier. It's sine a minus b. So it's r sine x minus alpha is equal to r sine x cos alpha minus r cos x sine alpha. We're going to compare that to sine x minus 3 cos x. So r cos alpha has to be equal to 1. And these have both got a cos x. What's left? R sine alpha equals 3. To find alpha, we find sine over cos. We need to be in degrees. So it's going to be tan alpha is 3 over 1, or just 3. And our calculator needs to be in degrees because it's between 0 and 90 this time. So it's shift tan 3, which is 71.6. So alpha is 71.6 degrees. To find r, we use Pythagoras. R squared is 1 squared plus 3 squared. So r squared is 10. R is square root 10. So we have square root 10 sine x minus 71.6 degrees. Hence solve. So it's sine x minus 3 cos x equals 2. So it's root 10 sine x minus 71.6 equals 2. So it's 2 over root 10. And then shift sign. Let's store alpha as a. 2 over square root 10. Shift sign that. So 39.2. So sine x minus 71.6 is 2 over root 10. Shift sign. So x minus 71.6 is 39.2 degrees. Or to get our second answer in sine, 180 minus the first one I'm going to store that as B. 180 minus the answer is 140.8. We're going to add 71.6 onto both of those. They'll still be between 0 and 360. So they are the answers we want. So this one plus alpha, 212.3. And the first one plus alpha is 110.8. Okay, one for you to try. See if you can give it a go. So we have cos, r cos x minus alpha. So it's cos A minus B. So r cos x minus alpha, using our cos A minus B formula, which is cos A cos B plus sin A sin B. Let's compare what we have. So we can see that r cos alpha is 4 and r sin alpha is 2. So tan alpha is going to be 2 over 4, which is a half. Shift tan a half, 26.6. Store as A. So alpha, 26.6 degrees. To find r, we use Pythagoras. 4 squared plus 2 squared equals r squared. 16 and 4 is 20. R is square root 20. We can simplify that. I'll just leave it as square root 20. So it's square root 20 cos x minus 26.6. Hence solve. So it's what we had before, which is now square root 20 cos x minus 26.6 equals 3. So divide by square root 20. And shift cos. So 3 over square root 20. And shift cos that answer. We get 47.9. So x minus 26.6 is 47.9 degrees. I will store that as B. Second answer in cos is 360 minus the first answer. So 312.1. And then if we add 26.6 to both of those, they will still be between 0 and 360. So add alpha, 338.7. Then B was 47.9 plus alpha, 74.4. So they are our answers. And one more question. Show that you can express 3 cos x minus 4 sin x in the form r cos x plus alpha. So r cos x plus alpha will be equal to r cos x cos alpha minus r sin x sin alpha. We're going to compare that to 3 cos x minus 4 sine x. So we can see that r cos alpha must be equal to 3, and r sine alpha must be equal to 4. Tan alpha, so the sine equation divided by the cos equation, is 4/3. Shift tan 4/3, 53.1. 53.1 degrees. To find r, we use Pythagoras. R squared is 3 squared plus 4 squared. R must be 5. So it's 5 cos x plus 53.1. Write down the maximum and minimum values of 3 cos x minus 4 sine x. So the cos part can go between 1 and -1. So if we times it by 5, the maximum is 5 and the minimum is -5. So the cos part can go between -1 and 1. So if we times that by 5, it's between 5 and -5. One for you to try. Give it a go. So this time we have cos a minus b, which is cos a cos b plus sine a sine b. Compare. So we have 7 cos x plus 24 sine x. So we can say that r cos alpha is 7 and r sine alpha is 24. To find alpha, we do sine over cos. We get tan. Tan alpha is 24/7. Shift tan 24/7, 73.7. Alpha is 73.7 degrees. R is Pythagoras. R squared is 7 squared plus 24 squared. It's another Pythagoras triple. It's 25. So 25 cos x minus 73.7 degrees. Write down the maximum and minimum. So again, the cos part can go between 1 and -1. Times it by 25. The maximum is 25 and the minimum -25.